0 and moment of z is equal to 0 is where this is what? This is free. Why is that? Okay, so if we were to go into this graph again, and I will come here, I'll paste this over here. Right? And if you see the similarities, so for this case, if I use this transformation, y is equal to 0, z is not equal to 0, but moment is equal to 0 at point A. And the other end, it is fixed. Yeah, at the bottom end is fixed, right? Regardless of which orientation you look at the other end, we have y equal to 0, z is equal to 0, moment about x is not equal to 0. There's a resisting moment. So if I were to sketch this structure on how it will deform, right, it will deform like this. Because the end is free, right, the deformation will look like this. Yeah. So over here, it's going to be 0 because I built in, and then it's going to do this. So this is our point P, where shape that's accentuated. So when that's the case, we now know that LE is equal to what? 2L, right? We know LE is equal to 2L. So now we have to apply the P critical is equal to pi squared. Young's modulus is 29 times 10 to the power 6. Now we are going to use I what? Already mentioned IXX. So we look at the value of IXX. IXX is at 118. Right? And then over here, the 2L, right? This is 2L and then the whole thing squared. Right? So we go to find L. So this thing will be half. And then we divide or multiply by a square root because it's L squared. Yeah, we put the square. Yep, this is correct. So pi squared multiplied by 29 times 10 to the power 6 multiplied by 118 divided by the P critical, which is set at what? Which is set at 33.3 or 33 times 10 to the power 3. So your L is equal to pi squared times 29 power 6. And let me write this better. Okay. Pi squared times by 29 power 6 times by 118 divided by 33 power 3. Square root the whole thing times 0.5 is equal to 505.8 inches. So what this means, right? What this means that the resistance of buckling is higher. So what this means, I'll write there. So resistance to buckling is better in the X, in the YZ plane. Because L is equal to 505.8 inches. Okay. Resistance to buckling in the which plane is that? In the XZ plane is only what? Is only, so L is equal to 449.2. Okay, inches. So the control, so L is equal to 449.2 inches controls. Okay. Why? If you use 505.8, right, the structure will buckle in the what? In the exact plane. Okay. So if L is equal to 449.2, the structure will buckle in the weaker plane, which is your XZ plane. Okay, so why this problem is so unique, like what you can see. Okay, let me I want to take a few moments to highlight the importance of this. Again, by looking at this, we can't really tell, okay, which is which is which plane will resist buckling better. Okay, why is because of the effect of I, the second moment of area, and our LE. LE is a function of what? LE is a function of how the ends are fixed, right? Then over here, we just learned it's not so obvious. Okay, we just learned that the rope can only withstand axial forces. Okay, I put down here truss member means only can withstand axial forces. Okay, it can only withstand axial forces. So then when you sketch this out, you realize that, hey, in the Z plane, the top end is in fact what we call as a what pin when the bottom end is fixed. Whether it's it pin or free, it will affect your what? It will affect your LE. Okay, then we calculate our length, which is 449.2. And then over the other side or the other plane, once we start sketching this, hey, the other end now is free. Okay, so if we think about it's free, because L now is become what? 2L, we thought it's going to be weaker. No, it's the stronger side because of what? The second moment of area is very high. It's 118, and the other direction is only what? 114 or 11.4. It's about 10 times stronger in second moment of area. Okay, or I. So that resistance push the LE to be what? 50 or 505.8, whereas XY is only what? 449.2, the lower value controls. Okay, so this question alone has a lot of layers. Okay, which this is the first time you're looking at it. It can be a bit confusing. My advice is you all have to sketch the diagram like this, like what I've just done down here. Okay, you all have to sketch diagram like this. It is so much clearer. Okay, and if you can sketch diagram like this, it'll be so much better. Okay. Okay. The next one I'm going to do now. This one is again not straightforward, very confusing. Okay, and how the question is phrased is also confusing, but I hope after my explanation you will not be confused. Okay, so now let's look at example number 2. Now the formula is easy. Okay, let me write down the example first. Okay, so you can again upload all these example on Avenue to Learn. We're going to do this one. We're going to do this one. I should not be doing this. Okay, so this is the problem now. Yeah. Right, so we know that we have to determine the largest load P, and the frame will support without causing the A36 steel member BC to buckle. Okay, so due to the fork end of the members over here, so you look at the ends down here. Okay, consider the support at BC to act as pins in the XX axis. So this is where it's confusing. Okay. And fixed support in the y. And there's reason for this. Okay, can fix support at y. Okay. I don't want you to focus on the axis down here. It can be very confusing, but I rather you visualize what is going on. Okay, more important. Okay. So the most important thing is we are going to analyze the member BC. Okay, we are going to analyze the member BC. So what is given to us is A36 steel. So if you look at the table A36 steel, the Young's modulus is equal to 29 times 10 to the power 6 psi. Okay, and if my memory don't fail me, it usually does. Okay, is the stress yield is equal to 36 times 10 to the power 3 psi. Okay, so let me crunch some numbers first. Yeah, okay, that's fine. Right, so they asked us what should the value of P be? Okay, so we want to determine P. Okay, we're going to determine the possible value of P. So given to us that the bar, okay, so we have 4 feet, 4 feet. Okay, A to B is 4 feet, B to the point is 4 feet, A to C is 3 feet. So we have to change everything in inches because our second mom or our Young's modulus and our yield stress are all in inches. So to change to inches is basically very straightforward. 4 multiplied by 12. Okay, and then this is 3 multiplied by 12. Okay, we are not given any factor of safety, so the formula that we're going to use is PCR is equal to pi squared E I over LE squared. Okay, right. So if we look at this structure, so the only thing that's labeled over here that we can see, so now everything that we do now is relative to BC. Okay, everything we do is relative to BC. So if we were to look at here, this is our X and this is our Y. Okay, so we know Z that's coming out is a dot, right? So sorry, the Z should be going downwards because if we use right hand rule, Z is doing downwards. Okay, so this, let me change the color. I don't think I can see properly with black. I'll change to red. Right, so Z is going downwards. Right, X, Y, Z using right hand rule. Sorry, not necessarily true though. I can use X to Y, so Z can be coming out. Okay, so this is Z. So if we view from not from the if we view from the side view, so this is our side view. This is from the plan view. Right. So now what we see now is the dot over here is our X. This over here is our Y. And this direction here is our Z. Okay. Makes sense, yes or no? Right. Some of you will say, Eugene, why that is important. Okay. So with this, then we can let me paste this into a different page. Right. So why this is important, right? Then we can sketch out the cross-section view. Okay, so if we sketch out the cross-section view, cross-section,